Now I'm going to start by looking at how many marks this question carries. As you can see, it carries 10 marks, so they're expecting quite a lot out of this question. So let's read it. It's a wooden spike consists of a hemisphere, a cylinder and a cone, joined together as shown below. Says note the diagram's not drawn to scale. The radius of the cylinder is 5 centimeters, so that is the radius there, 5 centimeters, and its length is 22 centimeters. That's that length here. Let's draw that in. Okay. The volume of the spike is 2,382 centimeters cubed. So the volume of the whole spike is 2,382 centimeters cubed. Calculate the length of the spike. So they want that length plus length of the hemisphere, which is 5 centimeters, plus the length of the cone. And we don't know that, so let's call that h. Now, we know we can calculate the volume of the cylinder and the volume of the hemisphere. And by calculating those two, we can subtract those from the volume of this whole shape here. And that will leave us with the volume of the cone. Knowing the volume of the cone means we can actually calculate h. And by calculating h, we can then calculate the total length of the spike. So let's start by doing that. So volume of hemisphere is equal to half a sphere. Hemisphere means half a sphere, so it's half the volume of a sphere. And if you look at the beginning of this paper, it will actually give you the equation for the volume of a sphere, which is 4/3 pi r cubed, and that is equal to 4/6 pi, and 5 cubed, 5 times 5 is 25, times 5 is 125. And all of that is 250 over 3. I should have changed that to 2/3, and then hopefully you can see that 2 times 125 is 250 over 3 times pi. So I like to leave calculating pi to the very end, as far close to the end as possible. So volume of cylinder, and this formula isn't actually given at the beginning because you expect to know it. Volume of cylinder it's quite a simple one if you think about it. It's the area of a circle here times the height of the cylinder, or the length of the cylinder. So let's write down the formula. pi r squared h. And I just want to distinguish it from that h, so I'll put a little c at the bottom, so height of cylinder. And that is equal to pi 5 5s are 25 times the length here, which is 22. And that equals, you can use your calculator if you wish, is 550 pi. So volume of hemisphere plus cylinder is equal to 250 pi over 3 plus 550 pi and that is equal to 250 pi plus 1650 pi all over, sorry about the line, over 3, which is equal to 1900 pi over 3, and I'm going to use 3.14, which is what it says at the beginning of the book, but you can use pi on your calculator as well, and that gives you 1976 centimeters cubed. So that's the volume of that. Now the volume of the whole spike is 2382, so we can say volume of cone is equal to 2382 minus 1976, and that equals I'm just making sure that equals 406 centimeters cubed. And 406 centimeters cubed equals 1/3 pi r squared h. You can get the volume of a cone at the beginning of the paper. You can get that formula at the beginning of the paper. So, and that's equal to 1/3 pi times 5 squared again is 25, because that's the radius of the cone. It's 5 centimeters still. So that's 5, so that's going to be 5 too. Times h. So that equals 25 over 3 pi h. So 406 equals 25 over 3 pi h. So what we'll do now is h equals 406, so I'm turning the formula around, and what we have to do is divide by 3 over 25 pi, so to get rid of that side, and we have to do that to the other side as well, so we're left with (3 over 25) gives us is 15.52 centimeters. What we've got is that length of the cone there. So total length of spike is equal to 15.52 plus 22 for the length of the cylinder, but remember there's also 5 centimeters for the hemisphere, plus 5, and what that gives us is 42.52 centimeters. Length of spike is 42.52 centimeters.